Hi everybody, it's Mrs. Mancuso, and today we're going to do organic chemistry. So, organic chemistry is all about compounds that have the element carbon as their backbone. Carbon is really unique. It's element 6. So it's 6 electrons, 2 on the first shell, 4 on the next shell. So having 4 valence electrons means that when you draw the Lewis dot diagram, you could actually show 1 on each side of the molecule. That means it has 4 openings for bonding. It could form a bond here, 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 and here. So organic molecules form long chains and even rings. So let's start looking into organic molecules. The first kind of organic molecule that you need to know is called a hydrocarbon. So we'll call this A. Our hydrocarbons are our molecules that only have carbon and hydrogen. We already know carbon is going to form 4 bonds, so I'm going to draw one for you. Carbon, carbon, carbon. 3 carbons here. Each carbon already has, well, this carbon already has 1 bond. It has 3 more openings, so I could put an H here, here, and here. This carbon already has 2 bonds, so it needs 2 more, so I could have an H here and here. And this one would have an H here, here, and here. They all are complete, meaning every carbon has 4 bonds. Hydrogen has 1 valence electron, and so to fill that first ring, you need 2. So it can form just a single bond, meaning 2 electrons shared. So right now, this molecule is C3H. You can count them up. 1, 2, 3, 4, 5, 6, 7, 8. C3H8. Now, to name this molecule, 3 carbons, you go to your reference table, and here on table P are the organic prefixes. You go to 3, and that means prop. Now you go down here. These are our homologous series of hydrocarbons. Every hydrocarbon is either going to be an alkane, an alkene, or an alkyne. Here are the 3. Alkanes always have single carbon-carbon bonds. Alkenes have a double bond between 2 of the carbons. And an alkyne with a Y has a triple bond between 2 of the carbons. So we have an ane. So to name this molecule, first, I write prop because that is the prefix for having 3 carbons. And then the ending would be ane because it's an alkane. Propane is the gas that's in a grill. So this hydrocarbon is a molecule that you actually are familiar with. All right, let's try a couple others. So let's say I have 6 carbons. First thing I want to do is put those hydrogens on it. And after a while, you don't have to write the hydrogens on the Regents exam. Please write the hydrogens. But on this, for practice, just draw lines. So here there's only 1 bond, so I would need 3 hydrogens to complete it. This one has 2, so I would just need 1 above and below for each one, and then the end needs 3. C6H. Now, there's 2 ways you can do this. You can either go ahead and count them up, or if I go to this again, my table Q homologous series of hydrocarbons, and I look at the alkanes because it's all single bonds, this is the general formula. 2 N's plus 2. So for every N, that means for every carbon, you are going to have double it plus 2 hydrogens. So let's work that out. If this is 6, this is 2 times 6 plus 2. So 2 times 6 is 12, plus 2 is 14. C6H14. That would be my formula. Now to name it, I go back to my list of prefixes. 6 is hex, and I know it's an ane. So the name of this is hexane. Hexane. All right, now I want to introduce you to a new word. It's called an isomer. And I'll get into alkenes and alkynes in a minute, but I really want to show you an isomer. An isomer are 2 molecules with the same molecular formula, but different structural formulas. So I just had hexane, and that was C6H14, but I'm going to draw you something else with 6 carbons. There is 6 carbons, so this also would be C6H14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it has the exact same formula, but it definitely has a different shape. And if it has a different shape, it's definitely going to have a different function. So this molecule, to name it, what I have to do, first I have to count the carbons in the longest chain. Here is my longest chain, or even if I started here, there's no more than 4 in any. So I'm going to count them out, 1, 2, 3, 4. If there's something exciting going on one end, I should always count from the shorter side. This one, it's equal. I could have counted from this side and it still would have affected carbon 2 and carbon 3. So my last name is going to be butane. How did I get that? Go over here, look up 4 carbons because that's how many are in my longest chain. So butane, and then I need to name my 2 branches. So there's a branch coming off the 2 carbon, and there's a branch coming off the 3 carbon. The branches both have 1 carbon each. So you go look up what the prefixes for 1, and it's meth. All branches end in the prefix YL. So this is 2,3-dimethyl-butane. All right, let me slow down for a second. You're probably like, oh my gosh, what is she doing? So I had 2 branches. They're both the same. That's why I wrote di. It'd be silly to write 2-methyl, 3-methyl. This just saves you some. You always put the location of the carbon that the branch is coming off of. So it came off of 2 and it came off of 3. It was a methyl, there were 2 of them, so dimethyl, and then my chain was a butane. Let me give you another one. All right, here's another molecule, and the first thing I gotta do is find my longest chain. So 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8. That is definitely my longest chain. Number your longest chain and have the side where there's something going on. So go ahead and circle this branch. I want to start counting closer to this action. So 1, 2, 3, 4, 5, 6, 7, 8. That means my last name is going to be octane, because oct means 8. It's an ane because they're all singles. Now I got to name this branch. First I start with the number that it comes off of, 3, and then there's only 1 carbon in the branch, so that means it's a 3-methyl octane. Again, branches end in YL, chains end in either ane, ene, or ine. All right, let's move forward. And so I started off here with hydrocarbons, and my first one was an alkane. So I want to add that to my notes. So I had a hydrocarbon, 1 alkanes, they are saturated. That means all single carbon-carbon bonds. All right, every carbon-carbon bond has to be single in an alkane. The ending is ane, and the formula is CnH2n plus 2. So however many carbons you have, to figure out your hydrogens, you double it and add 2. All right, now I'm going to move on to the next type. Type 2 is called an alkene. This is unsaturated. All right, so if I saturated a paper towel, it would mean like I had as much water as I could hold in it. Or if you had a saturated solution, you have as many grams of solute as you can hold in it. For a hydrocarbon, you have as many hydrogens as you could possibly add to each carbon. You do not have the maximum amount of hydrogens if you have an alkene or an alkyne, because you have either a double bond or a triple bond. That's going to limit the number of hydrogens. So that's why this is called an unsaturated hydrocarbon. It has a double bond between carbons. And you really only have to have one. You could have multiples, but everyone that we do in reagents chemistry, one double bond. So it looks like that. So let's do an example. Let's have 5 carbons in our chain, and let's put the double bond right there. Well, the first thing you want to do always is number the carbons. Number it closest to the action. So here is my action. It is shorter if I count from this side, meaning I come to it sooner, versus if I counted 1, 2, 3. All right? I put my last name, so this is 5, so I go look up the prefix for 5. Pent. So I go back here. Where was I even drawing this? All right. So, pentene. Ene is going to be my ending because it's an alkene. And then the double bond comes after the second carbon. So this shows where the double bond is. It always is the carbon before the double bond. All right? And pent tells me the number of carbons in the longest chain. And ene tells me there's going to be a double bond. So I'm going to give you one and see if you can draw it. So I want you to draw 3 methyl 2 octene. 3 methyl 2 octene. So pause the video and go draw it. Okay, you're back on the video because you already drew it and now you're checking to see if you're right. So octene, oct means 8. This is the first thing you look up. So I want 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Ene means I have a double bond. 2 tells me put the double bond after the second carbon. So 1, 2, there's my double bond. 3 methyl, this is my third carbon. My third carbon has a methyl. That's a methyl, 1 carbon chain coming off of it. And the last thing I have to do is put the H's on. You only have 1 bond, so 1, 2, 3. You already have 1, 2, 3, so I'm only going to put 1 H. It doesn't matter if you put it on the top or the bottom, as long as you don't put it in both places. Why would this be wrong? Sorry. Why would this be wrong? My carbon would have 1, 2, 3, 4, 5 bonds. That's not possible. That's too many electrons being shared. So I have to just put 1 H on there. This one doesn't get any H's. 1, 2, 3, 4 bonds, it's already full. But this carbon needs 3 H's. This one gets 2, this one gets 2, 2, 2, and 3. All right? Now I'm going to count up all of my carbons and hydrogens so that I show you the formula. So this is C, 1, 2, 3, 4, 5, 6, 7, 8, 9. H, now I want to figure out the number. So first I'm going to bring you to that table. We go to this table. Alkenes have the formula CnH2n. So that means all I have to do is double it. So if this is 9, this should be 18 if there's 1 single bond. One double bond. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes. All right, so C918, H18. So we are writing formula is CnH2n. So that's the formula if you have an alkene. And then number 3, alkyne. Also unsaturated, and it has a triple bond. Between the carbons. So let's draw one. Oops, sorry. Crazy. All right, let's just have 3 carbons in it. This is my whole molecule. So how do I go about naming it? First of all, go closest to the action to count. Here's my action. If I count this direction, 1, 2, 3. If I count this way, it's right after the 1. So I'm going to count this way. Number 1, number 2, number 3. You can flip-flop it back and forth, and that's why I have to pay attention to where I'm numbering. So, triple bond, prop. Whoops, I'm spelling that wrong. Prop means 3. So 3 carbons, so there's my prefix. Triple bond, Y-N-E. So this is propyne, and it's 1 propyne because the triple bond comes after the first carbon. So that's how you name it. Let me give you a more complex one. All right. Name that. All right, so pause the video, name it, then come back. All right, so you had me on pause, and now we're back. Now to name this. First of all, the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 6 is definitely my longest chain. Look up 6. 6 is hex. It's got a triple, so hexyne. That's the last name. Mark where the triple bond is. Carbon 1, carbon 2, carbon 3, 4, 5, 6. It comes after the second carbon. So 2-hexyne is the last name of this molecule. I have 2 branches, here and here. The 2 branches are both the same. They're both methyls. They're both coming off of carbon 4. So 4, 4, dimethyl, 2-hexyne. There's my name. All right, if you need more practice, there's tons of it in the packet. Go to it.